Hello friends, welcome to the channel. Let's get cracking with LeetCode problem number 9, Palindrome Number. Let's break down the problem. We're given an integer x and the ask is for us to return true if x is a palindrome and false otherwise. What's a palindrome number? It's any number which reads the same when read from left to right or from right to left. Let's look at the first example. Your x is equal to 1 to 1. It reads the same whether we read it from left to right or from right to left. Hence, it is a palindrome number. In the second example, we're given an input of -1 to 1, which is not the same when reversed because the reverse number would give us 1 to 1 minus. Hence, it is not a palindrome. In the third example, x is equal to 10. 1, 0 is not the same as 0, 1. Again, that's not a palindrome and hence we would return false. Again, multiple ways of approaching the problem. Let's look at one of the approaches where we'll use mathematical computations to reverse the number and compare whether the original number and the reverse number is the same. Now, for the reversal logic, it's a simple mod and mod multiplication division operation. Let's take an example of 1, 2, 3, 4. When you would essentially use modulus to extract the last digit. So 1, 2, 3, 4 mod 10 would give us 4. You multiply, so to begin with, reversed is equal to 0. You multiply 0 with 10 and you add 4. So essentially we're shifting left and adding the last digit that was extracted. And you remove that 4 from the original number using floor division. So that leaves us with 1, 2, 3. Again, at step 2, 1, 2, 3 modulus 10 would give us 3. 4 into 10 plus 3 would give us 43. And then 1, 2, 3 upon 10 would give us 12. Again, in the third iteration, 12 mod 10 is equal to 2. 43 into 10 plus 2, that would give us 432. And 12 upon 10 would give us 1. And the final iteration, 1 mod 10 is equal to 1. 432 into 10 plus 1 would give us 4321, which in this case is the reversed number. And 1 upon 10 would be 0. Let's look at the code for this. If x is less than 0, that's basically the second example where we would return false if it is a negative number. Let's take a variable called original to store the original number for comparison at the end. Reversed number is equal to 0. While x is greater than 0, reversed num is equal to reversed num into 10 plus x mod 10, and x is equal to math.floor x upon 10. And we would return reversed num equal to original. Okay, let's look at another approach where we do not essentially need to reverse the entire number. In this example, if we compare the first half with the reversed second half, and if that is the same, we have a palindrome. So your initial number is 1, 2, 3, 2, 1. Your reversed half is 0. Our condition is if the original number is greater than the reversed half, we continue. We strip off the last digit. So x becomes 1, 2, 3, 2. Reversed half is 1. We check if 1, 2, 3, 2 is greater than 1. We continue. Again, strip off the last digit. So x becomes 1, 2, 3. Reversed half is 1, 2. Is 1, 2, 3 greater than 12? We continue. Strip off 3, x becomes 12, and the reversed half becomes 123. Is 12 greater than 123? Fails the check, so we stop the loop. And we perform a final check where x is 12, reversed half is 123. We strip off the last digit and compare the first half of the first half of the number with the reversed last half of the number. So 12 is equal to 123 upon 10, which essentially means 12 is equal to 12. Hence, it returns true. Let's dive into the code. If x is less than 0 or x mod 10 equal to 0 and x is not equal to 0, return false. If x is less than 10, return true. So all single digits are considered as palindromes. Let's take a variable called reversed half is equal to 0, while x is greater than reversed half. Reversed half is equal to reversed half into 10 plus x mod 10. It's the same logic as before. X is equal to x upon 10, and we return x equal to reversed half or x equal to reversed half upon 10. This condition, the last condition is required if we have an odd number of digits, like we just saw in the example. Let's go ahead and run this. Okay, all my test cases have passed. I'm going to go ahead and submit. And that's quite reasonably well, I think about 8 milliseconds for the execution. Let's compare the space and time complexity for the two approaches. In the original approach, we were going through the entire set of digits. So it's O of n, where n is the number of digits, and the space complexity is O of 1 because we're using constant space. And with the optimization where we're just comparing half the digits, your time complexity reduces to O of log n, and the space complexity remains the same. I think that's it for now. See you on the next one. Thank you.